So we are running this thread T1 for 1000 times, and similarly we are running this thread T2 for 1000 times, and each of these we are doing the increment operation. So our basic expectation is when we started with 0, it should return 2000 as 1000 from this and 1000 from this. But in reality, we may not get 2000. Let's try to understand why is it so. Welcome to the Backend playlist. Hi, I'm Mohit Chhabra, ex-Salesforce, ex-Walmart, and in today's video we will discuss about multi-threading in terms of backend development. As a backend developer, you must understand that there can be huge load on the system. So the code that you write must perform well even on high scale. And one of the key concepts to handle that is multi-threading. So it's very crucial for us to understand the multi-threading concepts in terms of backend development. So in this video, we will discuss about thread creation, thread lifecycle, synchronization, executor service, and some other advanced concepts. As you can see, multi-threading contains the word thread. So let's first start with what is the difference between process and a thread. So when we talk about a process, it says an executing program with its own memory space operating independently. So you can see it has its own memory space. But when we talk about a thread is a lightweight unit of execution within a process. So this was our process. Inside this there will be thread. Now an important part here to understand is inside a process there can be multiple threads. Okay, so there is one process here, but there are many threads here, right? So in a process there can be multiple threads which share the same memory, but they are executing independently. So just remember, process has its own memory space, and a process can have multiple threads which can share the memory, but they execute independently. And because we are talking about multi-threading, which means multiple threads doing work simultaneously. So now let's see how does multi-threading helps in backend development. First use case is handling concurrent requests. So say this is your system and your system is getting multiple API calls, right? Because there can be many users, so you can get multiple API calls. So how will you handle all these API calls simultaneously? Using multi-threading. Apart from this, multi-threading also helps in executing the background task. For example, sending notifications, sending emails, or any task which is time consuming, we can handle that on background. So multi-threading helps in that. Another use case of multi-threading is parallel computations. As a backend developer, where you need to perform the computations in parallel, like data processing, streaming, so all that can be done via multi-threading. Now after this, let's talk about how can we create threads in Java. So basically there are two ways to create the threads in Java. First way is by extending the thread class. So here you can see in the example we have this class named as myThread, and it extends the thread class. After this, what we need to do is override the run method and provide our own implementation to it. The run method is a very important method which tells what work will be done by this thread. So whenever this thread will start, run method will be automatically called, and whatever is present in the run method, that will be executed. Here is an example. You can see this is a different class, and what we are doing is creating an instance of this myThread class which extends the thread class. So we have created an object of this myThread class. You can see myThread T1 equal to new myThread, and then we have started this thread. In order to start a thread, you need to call start function. So basically start method creates a new thread and it internally calls run method. So you don't call the run method by yourself, you simply start the thread, and run method is called internally. We will check the life cycle of the thread, but for now you need to remember, when you create a thread, you simply use the start method to start the thread, and it automatically internally calls the run method. And inside the run method you need to provide the implementation, which means what you want your thread to execute. Like we talked, you can do a lot of stuff from your thread, so whatever you want your thread to do, you need to define that in the run method. Okay, so this was the first way, by extending the thread class. Now after this we have another way to create the thread, that is by implementing the runnable interface. Let's see the code for this approach as well. Here you can see we have a class named as myTask and it implements the runnable. Earlier we extended the thread class, now we are implementing the runnable. Now inside that we are overriding the run method. Why? Because the runnable interface has this method run and we need to implement this method, and inside this method run we need to provide the body, like whatever we want our thread to execute, that should be present in this run method. Now let's see the usage of this. For example, this is another class. Inside this we are creating a new thread. How? By creating instance of this myTask class which implements the runnable. And then similar to what we did here, we are doing t1.start, which means we are starting the thread which would internally call the run method. Now talking about these approaches, first one being extending the thread class and the second one implementing the runnable interface. Which one is preferred? The second approach, that is implementing the runnable interface, is more preferred. Why? Because in Java we cannot extend multiple classes, we can only extend one class. The reason for this is Java supports only single inheritance. So in case your class extends the thread class, it cannot extend any other class, whereas you can implement multiple interfaces in Java. So when you implement the runnable interface to create the thread, you can implement more interfaces, as well as at the same time you can extend one more class because you are not extending anything here. So that's why implementing a runnable is a preferred way for creating the thread when we talk about these two approaches. Now you may have a question in mind, why we have these two ways to create the thread. We can understand that runnable has a method run, but how are we able to use this method run here when we are extending the thread? The reason for that is here we are extending the thread class, and the thread class internally implements the same runnable interface. So that's why we have two ways, either we implement the runnable or we extend the thread class which internally implements the runnable. Now there may be another question in your mind. When we say the thread class implements the runnable, it means it would have this run method. So either thread class would be an abstract class or it implements the run method. So which case is this? Actually, thread class is not an abstract class. It implements the run method of the runnable interface, but in the default implementation it is empty, so nothing is present in the run method of thread class. That is why you need to provide the implementation of the run method, and in that give the logic whatever you want your thread to implement or execute. Alright, the basic summary of creating the threads in Java, there are two ways. First is by extending the thread class, and the second is by implementing the runnable interface. In both of these approaches you will provide the implementation in the run method, which means this code will be run by the thread when it will be started. Now when you have to start a thread, you use the start method. You don't call the run method by yourself, you simply call the start method, and internally it calls the run method. And then talking about the preferred way, implementing runnable interface is better because Java supports only single inheritance. So if you extend the thread class, you can't extend any other class. But if you implement the runnable interface, you can extend any other class as well. Now after this, let's talk about the thread lifecycle. So these are the states of a thread. Thread can go to these states based on the situation. The first state is new state, which means thread is created but not started. So when we write this code, we have created a thread. Just imagine like my thread class implements the runnable interface or extends the thread class. We can assume that for now, and hence when we write this code, we have created a new thread. But because we have not used the start method, so this thread is not yet started. So it is currently in this new state. After this, we have a runnable state, which means thread is ready to run and it is waiting for CPU. So the execution of the threads depends on the CPU, right? So it has all the control. Now runnable is a state when the thread is ready to run, but it hasn't received a green signal from the CPU. Only once the CPU allows it to do something, it can do. And once it gets the green flag, it comes to the running state, which means the thread is actively executing. So whatever the code we have written in the run method, that is getting executed now. and the state is running. Now the next state is waiting or blocked. It means that the thread is waiting for a resource or a signal. There can be multiple scenarios in which thread can go to the waiting or blocked state, and whenever that happens, the thread comes to this waiting or blocked state. You can also read few methods are also available through which you can put your thread to be in the waiting or blocked state, and when that happens, this state will appear to the thread. And finally we have the terminated state, which means that the thread has finished the execution. So whatever code we had written in the run method, the thread has already executed that. So these are the states in which the thread can go, or you can also say this is a life cycle of a thread. Now let's talk about some of the thread methods. The first method is start method. We also saw this method in the code example earlier. So what it does, it starts a new thread for execution. So you need to remember that we never call the run method by ourselves. We simply call the start method, which would internally call the run method, which brings us to the next method that we are going to talk about, which is the run method. So in the code example, you might have seen that we implemented the run method. Inside that, we will give the logic whatever we want the thread to execute or implement. So basically it contains the task logic for the thread. So apart from start and run, we also have a sleep method, which takes the milliseconds as a parameter. What it does is pauses the execution of the current thread. For how much time? Whatever time you give in the argument in terms of milliseconds, for that period of time your thread will sleep. Then we also have a join method, through which it will wait for a thread to complete its execution. Then we also have a yield method, which will give hint to the scheduler to give other threads a chance. So this can also help in removing the problem like starvation, where only one thread is getting a chance and other threads are not getting a chance to get executed. So you can clearly see via these things you can go to the state like waiting or block that we just talked about in the life cycle. Like this, there are many other methods related to thread, but in this video we are focusing on the backend development, so we won't discuss about each and every method in the thread. But in case you want to know more, put that in the comment section and I'll create a separate video related to threads so that you can get more idea about it. Alright, so now that we have talked about how to create a thread, what is the life cycle, and what are the basic thread methods, now let's move back to the main topic, which was related to multi-threading. So now in this code example, what I'm going to do is to show you a very basic problem that comes in multi-threading, which is the race condition. And when does this happen? When two threads try to modify the shared data at the same time. Let's see that with this code example so that you get more clarity about it. You can see we have this counter class. It has a variable count, and then we also have a getter method here, and we also have a setter method here. In the setter method, what we are doing is basically this setter is an increment method where we are simply increasing the count every time. Now let's see the usage of this class. You can see this is another class. In this we have created the object of this counter class. Now we have two threads here. We have created thread 1 here, T1, and thread 2 here. Don't get confused by this. This is basically the lambda expression. We discussed about streams and lambda expressions in this video related to backend. So if you're getting confused here, you can refer to this video. It is basically reducing the code here, but internally what this means is we have overridden the method run, and inside that we have given this implementation. So this is the implementation inside the run method. This is just a way to make the code smaller using the lambda expression. Similarly, in the thread 2 we have given this implementation in the run method of T2. So basically we have created an anonymous inner class here, and in that we have given the implementation in the run method here. Now after that what we have done is started both of the threads, T1.start and T2.start, which would internally call their run methods. And after that we have also applied join. Join, as we discussed, it waits for a thread to finish. Now when we print the final count here using the getter method of count, the problem is the count may not be 2000. This is happening because here two threads are trying to modify the same variable simultaneously, because here two threads can enter these methods like getters and setters simultaneously. So we are running this thread T1 for 1000 times, and similarly we are running this thread T2 for 1000 times, and each of these we are doing the increment operation. So our basic expectation is when we started with 0, it should return 2000 as 1000 from this and 1000 from this. But in reality, we may not get 2000. Let's try to understand why is it so. So here I will tell you why we are not getting 2000 with that. We will get some random value which would be lesser than 2000. So here is our increment and get count methods, and here is the analysis. So basically when we are doing count plus plus here in the increment method, it is actually not atomic. Now what do we mean by that? Basically when we write count plus plus, it looks like a one line, but actually it is doing three separate steps. How count plus plus is made of three steps? Because count plus plus is equivalent to count equal to count plus 1. So the first step is to read the value of this count variable from the memory. Whatever this value is, say for example, we say count was 5 in memory. So first step is that it will fetch it from the memory. So after this, we have the second step, that is to increment the value, because we are doing count plus 1. So it will do 5 plus 1, that is 6 as a second step, and then the third step would be it would write the value back to the memory, because we are doing count equal to count plus 1. So whatever value we found out, we need to put that back in the memory. So count value equal to 6, putting that in memory is step number 3. So count plus plus is basically made of these three steps. Now imagine like two threads T1 and T2 are running at the same time. So first let's say T1 reads count equal to 5. T2 also reads count equal to 5. Now T1 increments. So result will become 6. And at the same time T2 increments. So because it had the value of 5 from the memory, it will also make result as 6. So both write back count equal to 6. So instead of count becoming 7, count is remaining 6, because when both of these read from memory, the value of count was 5. Now how is this happening? Because both of these threads can enter this method at the same time. Similarly for this, both of the threads can enter this method at the same time. That's why instead of getting 7, we are getting 6 here. So even though two increments happened, but the final result increased only by 1, and this is called the race condition. That is, the threads race to read or write the same variable at the same time. And because of this, the final result when we are running the thread for 2000 times, 1000 by T1 and 1000 by T2, the final result is often less by 2000, and the value may vary. Sometimes it will be 1768, sometimes it can go 1923, whatever. It would be lesser than 2000, and we can resolve this problem by modifying this part by using keyword synchronized, so that only one thread can enter the method at a time. So how can we resolve this problem? We can resolve this using synchronization. So what I'll do now is modify code in this class. I'll create a separate class so that we can easily see the difference. And here is the code. You can see I created a separate class. It has the same integer count variable, same methods increment and get count. In the increment, same as earlier, we are simply doing the increment, and in the getter we are simply returning the count. The only difference that we made is using the synchronized keyword in both of the methods. So in the increment method and in the get count, now we are using synchronized keyword. Here you can see there was no synchronized keyword. It was simply public void increment, public int get count, and here you can see it's public synchronized void increment, public synchronized int get count. So we are simply using synchronized keyword. And what's the value of this? When we use synchronize, it puts a lock on this object. It means when we create two threads and they try to enter this method, so say for both of the threads we are calling increment, only one thread at a time can enter this method because we have used synchronized. So basically it ensures thread safety. So at a time only one thread can enter these methods, as synchronized puts a lock on it. Now why our problem got solved by using the synchronized keyword? Because synchronized ensured that only one thread can execute the method at a time. So we saw in the problem statement multiple threads were able to enter the method at the same time, and this is resolved by the synchronized thing. So basically when T1 is inside the increment method, T2 thread must wait. It cannot enter the same method alongside with T1. So this makes count plus plus operation atomic. So basically read, increment, write is happening together. The same example that we took earlier, if count value is 5, say first of all T1 entered the method, it would increment it to 6, and once T1 has exited the method, only after that T2 can enter, and hence it will get the updated value 6, and to which it will update by incrementing and making it 7. So in this way no increments will be lost and the final result will be always 2000, that is the expected one. So we just saw like using synchronized keyword we were able to solve the race case condition, but using synchronized is not the only option. We have another option. Say for example in this case earlier we were using int for the variable count. Instead of that we could use atomic integer. So instead of int we have used atomic integer here and also initialized it in the same way, giving the initial value of 0. Now in the increment method, instead of writing count plus plus, which we saw is creating problem because it is not atomic, we are writing in this way, count dot increment and get. This is the method which is provided by atomic integer class, and it makes the operation atomic. So now we are not doing count plus plus, we are doing count dot increment and get. Although it is doing the same work, it is just incrementing by 1, but it is making sure that this operation is atomic, so the race condition won't occur. So even if two threads come to this method at the same time, this operation is atomic and hence we won't get the issue. Similarly for the get count method, earlier we were simply returning the count. Now we would do count dot get because count is now atomic integer. So we have solved the problem. Earlier the problem was count plus plus was not atomic. We have made this operation atomic, and that's how we can simply solve it. And you can see we have not used the synchronized keyword here. Now this way is better as compared to using synchronized keyword, because when you use the synchronized keyword, the complete method only one thread can enter at a time. So due to locking, synchronize makes the performance slow. In this method you can't visualize that because there was only one line, and that was causing the issue because it was not atomic. But say you have like 20 lines of code in the method, if you use the synchronized keyword, then it would be locked. That is, only one thread can enter the complete method at a time. So that can cause the performance issues. Whereas by using this approach, here we used atomic integer, we solved the problem only where the issue was coming. Say for example, there were 10 lines of code, only one line had the issue which was not atomic. We made that atomic, and hence it is much faster and also solving the problem. Alright, so this might seem a bit confusing or overwhelming to you, so I can give a brief summary. So first of all, the problem was coming because count plus plus was not atomic. So this operation was causing the race condition. So when two threads try to do count plus plus, some of the increments may get lost. Why? Because count plus plus is not atomic. The same thing that we discussed earlier. Okay, and how can we solve that? First way is using the synchronized keyword. That will make the complete method, this method, atomic, as it will allow only one thread to enter the method at a time. So it will apply the locks. Now second way is whatever operation was not atomic, you make it atomic. Here because we were using int, so we used atomic integer and used its method like increment and get, which is atomic. So we are solving the problem. And both of the approaches that we discussed, atomic integer was better because synchronized is slow. You are applying the lock on the complete method, so the performance will go down. So initially my plan was to discuss about the executor service as well in this video, but I think it is getting overwhelming. We have discussed a lot of things related to multi-threading in this video, so we will discuss about that in the next video. So in case you have any doubts, put that in the comment section. I'll try to help you out. If you found this video helpful, press the like button and share it with your friends so that all of us can learn and grow together. Alright then, this is Mohit Chhabra signing off. Subscribe to the channel and thanks for watching.